Okay. Computer viruses cause enormous economic harm to businesses through costs associated with preventive measures, data recovery, and damaged equipment and reputation. The speed at which viruses can spread makes it difficult to manage and attack. Suppose a new virus has created and initially affects 100 computers in a large corporation through a single email. That's just terrible. Let t equal zero by the time of the initial infection, and suppose that the number of computers infected within the corporation doubles every 47 minutes. This infection is finally brought under control 6 hours later. Okay, so the first question says, how many computers are affected at the 1 hour mark? Now, to do this problem, we have to convert an hour to minutes. And there are 60 minutes in an hour. And the equation that is used is C of t is equal to 100 times 2 to the power of t over 47. So this is 47. It takes 47 minutes for the number of infected computers to double. So the first equation is 100 times 2 to the power of 60 over 47, which the answer to that question is there are 242 computers infected. Now the second question says, how many computers are infected after another 30 minutes? So we just take the 60 minutes that we had in the first question, and we add a 30 to it, and we change what the value of t is. So t equals 90 now. T is time. So now the equation is 100 times 2 to the power of 90 over 47, which gives us an answer of 377, and there are 377 computers infected after 90 minutes, or after another 30 minutes. There are a total of 377 computers infected. Now the third question says, how many computers are infected when the virus is finally brought under control? The prompt says that the infection is finally brought under control 6 hours later. So we have to convert 6 hours to minutes. So there are 60 minutes in an hour, so 60 times 6 is 360. So the equation is 100 times 2 to the power of 360 over 47, which gives us an answer of there are 20,219 computers infected after 6 hours when the virus is finally under control. Now, the fourth question asks, a second virus is detected a week later, and the number of computers it affects t minutes after initial infection is estimated to be 50 e to the t over 110. To the nearest minute, what is the doubling time for this virus? So, we know that when t equals 0, anything to the power of 0 is 1, so when t equals 0, the amount of computers infected is 50. So if we double that, it's 100. Okay, so 50, it's 100 divided by 50 is equal to e times t, e to the power of t to the t over 110. Which is just 2 equals e to the power of t to the over 110. Now, what we have to do to solve this problem is use the natural logs. Ln of 2 is equal to ln of e to the t over 110. And using I forget what the law is called, but since t to the 110 is in the power, you can put it in front. So ln of 2 is equal to t over 110 ln of e, and ln of e is equal to 1. Ln of e always equals 1. So ln of 2 is equal to t over 110 times 1. And you want to find out what t is equal to, because we're trying to find what the doubling time is. So you multiply 110 on both sides. So now t equals 110 ln of 2. And if you put that into your calculator, you get 76.246. So the time for the amount of infected computers to double is 76 minutes.